See how they get closer together? Now let's flip it over. Try it this way. What happens to them? Yeah, they get spread apart. So it's tension compression. And so generally what happens is the material on the bottom of your structure is going to get pulled apart and the material on the top is going to get pushed together. So if we go back to our little buffer, our little triangular truss, now we don't really have as much of a compression member because we don't have a single member up here to get compressed that's acting in this direction. But it makes sense then that this is going to be getting pulled apart. And so you have a force that's acting inward here. Like this beam is being stretched and it's got to pull it back together. So that's a force acting on. Whereas these two are both pushing out. And so they're members in compression. So pretty much think about it, is it like a rubber band that's being stretched, it's tension? Is it like, you know, a piece of whatever steel or whatever that's getting smushed together? That's compression.
Like a marshmallow.
Now, the interesting thing, so what we were talking about,
my marshmallow. I thought that was smart.
we were talking about before with cardboard.
Brad's like, shut up.
You've got your tension, which is pulling it, and you've got your compression. Now, which seems stronger there? This or that?
Tension.
Yeah, tension, clearly. Because, like we were talking about before, you've got buckling. If it wasn't for buckling, they'd be equally strong, but because you have buckling, your compression members fail significantly earlier. So, well, okay, let's before we get into that too much, let's do some equations. So, let's say we made this a little bit more complicated. I'm just going to draw lines with dots instead of drawing linkages.